All right, so this is on module 3, page 48. So we're going to start with this first section here, the getting started, because it has some information that we need. Okay, so you got a parent-teacher organization wants to sell long-sleeve t-shirts as a fundraiser. The business manager found a company that will charge $4 for each long-sleeve t-shirt and then a setup fee of $160. So that's how much their costs are. So I'm going to do a cost function right here. I'm going to let X equal the number of t-shirts. And so we would say that, let's say Y is the cost. So we would say Y is equal to $4 per t-shirt times the number of t-shirts, which is X, and then we're going to add the $160 setup fee. Okay, so that's the cost function there. Then it says that the chairman of the fundraising committee suggested selling them for $8 a piece. So this is going to be your income, the amount of money that you bring in, which we'll use X and Y again. Even though Y in this case represented cost, you could think of Y in terms of like the amount of money that you bring in, but it still represents cost in that function. Okay, so in this one we have $8 per shirt times the number of shirts. That's how much money that you would bring in. Okay, now they want to know when you're going to make a profit. Okay, so we want profit. Profit is where you take all of your income and then you subtract out how much money you paid out to actually make the t-shirts in the first place. So income minus costs. Well, if you look at your two functions here, you've got income, which was 8x. That was what was represented by income. And then costs, which was represented by all of this right here, which was 4x plus 160. Okay, so that would be your profit. So if you distribute your negative, then you've got 8x minus 4x minus 160, which would equal 4x minus 160. Now they want to know when was your parent-teacher organization starting to make a profit? Okay, well let's find out when the profit was nothing, was $0. So let's set the profit on the left side. If we just bring this word down, profit. So let's find out when we make nothing. So we'll let profit equal 0, x minus 160. So if we bring the 160, add 160 to both sides, you get 160 is equal to 4x. Divide by 4, you get x is equal to 40. So at 40 shirts, this is called your break-even point. You're breaking even because you're not making any money. Okay, so your income would actually equal your cost. And you can actually plug that back into each equation. So for example, if you plug that into y equals 4x plus 160, you could plug in y equals x equals 40. So I'm going to plug in right here. So you get y is equal to 160 plus 160. So therefore y equals $320. So your cost at that particular point in time would be $320. What would your income be? Well, if you plug in onto your income function, you would get y equals 8x. So y is equal to 8 times 40. And so y is equal to $320. So your income would also be $320. So that's why you're breaking even, because you're making as much as you're spending to actually make the t-shirts. And so therefore your profit is nothing. That's why we plugged in 0 for profit. Okay, so what would happen after that? What if you did 41 shirts? Well, you can easily see that if you plugged in 41 into each equation, your income is now going to be higher than your actual cost. So now you're starting to make a profit. So we would say that 40 is the break-even point. All right, let's move into the next section here. Okay, so it says, consider the fundraiser being held by the parent-teacher organization described in the previous activity. Shirts are sold for $8 each and cost $4 each to make plus a $160 setup fee. Write an equation to represent the organization's cost in dollars to buy the long sleeve t-shirts, and then describe what your variables represent. So we've already done that. If you look up above there, we've already actually done that. So you guys can fill that that stuff in based on your equations that we found before. And then also you're going to be able to do this one. You should be able to have an income equation as well. So if you plug each one into your table here now, I'm just going to get you started on the table. So they wanted you to make a table. We know that our break even was 40 shirts, but they're showing like different values of the number of shirts here. So we got X is the number of t-shirts like I used. And remember that your cost function was 4x plus 160. So you got to plug that one in there. And then your income function was 8x. And then remember your profit was the two of those subtracted from each other. So if I go back up here, we found that our profit was 4x minus 160. So you're going to plug that one right in here. And then you should be able to plug in your X values for each one. So for example, at 0 t-shirts, 4 times 0 is 0, plus 160 gives you $160 cost. And then 8 times 0 is 0, so your income would be 0. And then of course, if you plug 0 into your profit function here, 4 times 0 is 0, minus 160 is a negative $160. So you're looking at a $160 loss if you order 0 t-shirts and sell 0 t-shirts for that matter. And then you can fill in the rest of the chart there. So I want you to go ahead and pause the video for a couple minutes, fill in your chart here, and then resume the video when you're ready. Alright, so now I've got my my chart filled in here. Now we're going to go to the upper bound and lower bound. If you notice down here, I want to make a comparison here. It says for the number of long sleeve t-shirts here, it says the lower bound is 0. In other words, what's your lowest amount of number of t-shirts? If you look in this column over here, you see that your lowest value is 0. So that's why they put a 0. Now why on earth did they do an upper bound of 50? Well, because you know, if you look at this value right here, if you look across, you're like, okay, well, how much was our profit? Our profit was 40 bucks, right? So that's just past the break-even spot, right? But then as soon as you get into 100, I mean, now you're starting to make real lots of money and everything, and we're not going to necessarily need this point on the graph. So that's kind of why they're just eliminating that particular one there. So if we eliminate that one, then we're just going to go from 0 to 50 on our graph. That's why they did that. And then they're counting by an interval of 2.5. Kind of a weird way of counting, but whatever. Okay, so we go to the amount of money that we make. Well, we go from 0 to 400. That was based on our actual income right here. So we went from 0 all the way down to 400. So that's what they did there. Okay? And then they're counting by an interval of 20. So when you get to your graph, remember the x-axis was number of t-shirts. We're counting by 2.5. So each of these is 2.5. So therefore that would be a 5, 7.5, 10, 15, 20, 25, 30, 35, 40, 45, and then the maximum here is 50. And then the y values we're counting by, let's see, we were counting by 20, so 20, 40, 60, 80, 120, 160, 200, 240 up here, whoop, 280, that was a terrible 280, 280, 320, and then we're going to go 360 up here, and then of course 400 is at the very top. Okay, so now we have our stuff labeled here. So we can actually go through, we can graph our values now for, let's go back to our T-chart here. Remember, we're not going to do this bottom one here. We're going to do the cost and the income column. So if I do the first ordered pair, I would have, let's do the cost function here. I'd have 0, 160. Okay, so I take 0, 160. 0 shirts, I make 160 bucks. I put a point right here. And then I would do the next one, which would be 10, 200. So 10, 200, which would be, looks like right there. And then let's graph one more. Let's see, 20, 240. 20, 240. Looks like that point right there. And then it just keeps going. Okay, so I'm just going to draw a line here. Goes from there. Trying to get that as accurate as possible, but you kind of get the picture. Okay, so that is going to be our, what was that? That was our cost function. So I'm going to label that cost. All right. So then we're going to go through and we're going to do the same thing. We're going to label the income graph. So I'm going to start with 0, 0 using these y values. So now I have 0, 0. And then I go back up here and I say, okay, that's 10, 80. So 10, 80 would be here. And then maybe we could just do one more, I don't know. 20, 160. So we're going to do 20, 160. You know, maybe I'll just do one more after that. 20, 160, 35, 280. 35, 280. Yeah, that's probably better right there. Okay, so now I'm going to go ahead and put a line through those. I'm trying to get this right. Let's see, do I have my... I'm a little bit off here. Yep, I can tell I'm a little bit off here. This point was a little bit too high. There we go. 280. Let's graph that one again. 35, 280. See, now if your graph is off, you're going to be in deep water here because it's not going to come together very nicely. Okay. That's sort of good. I'm a little bit low there, but I'm not even going to adjust that. I'm just going to kind of go with it. All right, so now we need to answer some questions down below here. It says to use your graphs to answer each question. Okay, so we're going to determine the number of long sleeve t-shirts for which the cost is greater than the income. Well, if you go up to the graph, look at your cost line. When is it above the income? I should have labeled this one. This is income line. You could label down here too, income. So if you look at your graphs, you go, okay, well, when is the cost line above the income? Well, the cost line is above the income right along here where all of these values were above the income until we reach, remember, that equilibrium point, which was 40. And you notice that my graph, remember, my graph is a little bit off. So this was your break-even point should have been like actually right here. And see how that graph is off a little bit? So actually, let's adjust that. Yeah, it's a little bit better. But it's still, my points are off. This kind of illustrates something, and I did this on purpose because it illustrates that if your graph is off when you draw it, you're not going to be able to really analyze exactly where it's at, and this is the downside of the graphing method. So if you can't get your graphs super perfect, then you're in trouble. Okay, so this is supposed to be our equilibrium point. Remember, our break-even point when you had 40 shirts, and then both the profit and the income and the cost were $320. That ordered pair right there. Okay, that should break even. So cost is above all along here. So we would say anywhere below 40, right? All the t-shirts will say X is below 40. But X has to be above 0 because you can't have negative t-shirts. So you would say anywhere in between 0 and 40. Okay? And then it says the next one, it says when is determine the number of long sleeve t-shirts for which the income is greater than the cost. So we go back up here. When does the income start to rise above the cost? That's when your income graph is now above, which is up here. You see how the cost function is going to continue this way. Now your cost is down here, whereas your income is up there. So you're looking at values that are above 40. So we would say the number of t-shirts would be X is now above 40. And then when are they equal? Well, we've solved that in the getting started portion, 40 shirts. Okay, and then we've already we can verify that algebraically like we did before, but there's another way to do it as well. Recall, let's go back to our actual equations. One was y equals 4x plus 60. The other one was y equals 8x. I'm going to write these down here. Y equals 4x plus 60 and y is equal to 8x. Okay, plus 160 rather. So if you notice, if we set each of these equal to each other, since y equals this and y equals this, we want these two values to equal each other. The y value here equals the y value here. So therefore we can set these two equal to each other. So 4x plus 160 is equal to 8x. So you can set these together in an equation, subtract 4x from both sides, you get 160 is equal to 4x, and then divide by 4, you get x is equal to 40. So that's another way of actually verifying algebraically or finding the break-even point. Set your two equations equal to each other, where the profit, or excuse me, the cost is equal to the amount of income. All right. So like we mentioned before, the point of intersection, that's going to be your break-even point, where your actual income and your costs are going to match each other. So we said on that one that the break-even point was 40 shirts. $40,320. 40 shirts, $320. What's the profit at that break-even point? Remember, your cost and your income were the same, so your profit on that was nothing. You made $0. And remember that the cost was $320 at that spot, and the income was also $320. And then finally, number 9, it says, what do the coordinates of the point of intersection mean at 40 shirts, we would say, both cost and income, because that point was on both lines, are $320. Okay, we can get rid of this. We've kind of stated that over and over again. So there you have it. So that's essentially what you're doing with this. Now we're going to get into something called systems of equations, and that's what essentially this is that when you graph two lines, sometimes it's more than two lines later on as you get into higher math, but when you graph two lines like so and you have x and y, two variables, it's called a system of equations, and the solution to the system is where those two equations will intersect. So that $40,320, that was the solution to the system of equations. And the system was, you know, y equals 4x plus 160, and then y is equal to 8x. So there's your system of equations right there. And then this is the solution. Why? Because if you were to plug in 40 into x, you would get 320 for this one. And then if likewise, if you were to plug in 40 into x in this equation, you would get 320 as well. So this ordered pair satisfies or makes both of these equations true at the same time.